So in this video, we're going to do regression modeling with exponential equations. And so what we want to remember when we're doing the modeling with data is we're looking for data that follows the pattern set by toolbox functions. And for exponential functions, this right here was the toolbox function, e to the x. And if we have data that looks like it's growing up from a horizontal asymptote, and that has the same type of curvature that the toolbox function e to the x has, then we might be able to model that data using e to the x or an exponential function. If we reflect the toolbox function right here over the output axis, we get a function that as you move from left to right decays towards a horizontal asymptote. So if we have data that looks like it's decaying to a horizontal asymptote, we might be able to use an exponential model to model that data. We want to remember that the data, if it's going to be modeled with an exponential function, doesn't need to have this extreme rise or this extreme decay, because the scaling of the axis is what dictates how extreme the decay or the growth looks. So for example, if I go up and select the Move Graphics window option, and then I hover over the input axis until I get the double arrow, and I left click, I can change the scaling on the axis. And notice, depending on how I scale the axis, I can take an exponential growth function or exponential decay function, and I can make them look like linear functions depending on how the axis has been scaled. So sometimes when you're looking at the data set, you're looking to see if there's just a mild curvature, a mild growth curvature or mild decay curvature to the data set you're working with. And that might indicate that the exponential model is an okay model to use. So again, we want to look at the data in a scatter plot and see if our toolbox function will model it, but we need to be mindful of the fact that scaling changes how a toolbox function looks. So it might be subtle curvature that we're looking at that's making the data nonlinear. So in this case, the data set that I have is altitude in feet. So this is feet, with 0 is going to mean sea level, so negative numbers would mean below sea level, so places like the Dead Sea or the desert down, what's the desert down in California? I can't think of it right now. But we have places where we have dry land below sea level. So negative numbers would indicate below sea level. Positive numbers here represent elevations or altitudes above sea level. And then we have air pressure measured in millibars as our outputs. So air pressure, the pressure you experience in an atmosphere, is dependent on your elevation. The further you are from the center of gravity of the planetary mass that's holding the atmosphere in, the less the pressure you have. So again, this is going to walk through just like it did with linear and quadratic models. If you want to model data, make sure your input column is first and your output column is second, so that Microsoft Excel will guess correctly as to which variable is the input variable and which variable is the output. So input first, output second. You just highlight the data you want to model. Then you go to Insert. And over in the Charts menu, you pick Scatter Plot. You do not pick any of the Connect the Dot options. You just do Scatter Plot. You just plot the data points. Once the chart's up, you want to right away go in to the layout and make sure you pick a layout that's going to let you put labeling on the vertical and horizontal axes. This series, unless you are modeling multiple data sets in the same graph, the series isn't needed. So you just delete this little piece. Put our title in. Titles should be all caps except for the words in English that are traditionally lowercase, like of and. So this is going to be pressure as a function of altitude or elevation, altitude. All caps except for the words you would generally not capitalize. The vertical axis, the outputs are pressures. So I'll put pressure. And in parentheses, I want to include the units of measure. So this is pressure measured in millibars. And the inputs are our elevations or altitudes. So this is altitude. And our altitudes are measured in feet. I also think that the horizontal lines don't add much and actually make things look a little bit worse. So I usually like to format my grid lines and then turn off, so by selecting no line, turn off those grid lines unless I really have a good reason for keeping them there. And then we're going to add an exponential model to it. The data looks like it could be modeled with a linear function. So when I left click to select any point and then right click to bring up my add trend line, I could add a linear trend line to it, but you can see that the data points vary a little bit from the linear function. The linear function's fitting it pretty well. If I look at the r-squared score that goes with it, it's 0.978. And what we want to remember is the closer the r-squared is to 1, the better the model is fitting the data. So the linear model is fitting the data pretty well. And we could probably use the linear model within reason. But it turns out that if we fit an exponential model, so see here is the option to do an exponential model. This is going to do an exponential function base e, that we get a r-squared score of 0.9987, so even closer to 1. And we can see that the regression line actually fits the data better than the linear model did. So we want to make sure that we add both. We want to add both. It took me out of the menu before it let me add in. Go back here, right click, add trend line, exponential function. We're going to add the equation and the r-squared value to the chart. And then what I'm going to do is get this into a text box. So I can see on the e I have this exponent -1e04x. We'll talk about that in a minute. But first I'm going to cut this out of the box that it came in because I'd like to format it, and it's easier to format it in a text box. So if you right click, you notice there's no option to cut. So what I can do is use the keyboard shortcut for cutting, which is Control X. And then I can go up to Insert. I can pick Text Box. I can then add the text box and paste my information into that text box. And then I can make the font a little bit bigger so it's easier to see. I could format it in math type if I'm on a PC. I don't think Google Chrome will do this, and I don't know about MacBook, but if I go Alt equals, it formats it in math type. And math type always adds extra spacing in when you do it this way in Excel, so I've got to delete that extra spacing. And now I need variable names that make sense. So I'm not going to use y. Y doesn't make any sense in the context of this data. The outputs are pressures, and pressures as a function of altitudes or elevations. So this x over here, I'm going to want to change that x to an a for altitude. And then I need to figure out, what do I do about this -1e -0.4? So here's what's going on. So when you see that, this is calculator speak for -1 times e represents base 10 times 10, and then what comes after the e is the exponent. So this is really a -0.4 or just -4. So this number is really -1 times 10 to the -4th, or as a decimal it would be -0.0001. So what I would want to do is replace this mess up here with -0.0001 times a. So I'm going to go ahead and clean that exponent up so that it's in a format that a person would typically expect to see. So I'm going to grab this exponent mess here, and if I'm in math type, which in this case we are in a math type box, I'm going to do an caret, and then I want to put the exponent in parentheses. So I go negative 0.0001 times altitude. And then if I just tap the space bar, if I have it in parentheses, it'll lift it up into the exponent position for me. If I don't have math type, because I'm on a Chromebook, for example, then I would need to Google how to put something in superscript when I type. And that's going to depend a little bit on your computer. So anyways, now I have something that's formatted, that's kind of lab report ready, and I have a model now for pressure as a function of altitude that I could bring off onto a piece of paper and use to answer questions. And we're going to go ahead and answer a few questions about this model here in a minute. So if I go over into GeoGebra, I've already gone in and typed in the model that I got out of Excel into my algebra window by typing it into the input bar here at the bottom. And what you'll see is that negative 0.0001 has been rounded to 0 by GeoGebra. And so the way that I can fix that is I can go into options and use rounding and say I want to carry my computations out to more decimal, up to more place values. And if I do that, as long as I select sufficient place values, I will be able to see everything that I typed. Even though it's pressure as a function of altitude, because now I'm in a computer algebra system, I'm going to have to use X for my input variable instead of A. Although A, if you're writing a book or a lab report, would be what you would want to use. So that's the first thing. Now, GeoGebra is giving me a standard viewing window. When I right-click on an axis, see it's got standard view, zoom to fit. So right now I'm in standard view, and what's happening is I'm not seeing the graph because it doesn't work with standard view. Remember, the input values for our data set went from 0 to 10,000, and our outputs were between 265 and 1013. So I have to rescale the window in order to see anything. So the horizontal axis is my altitude axis, and I was getting altitudes all the way out to 10,000. So the way that I can adjust the axis in GeoGebra is I can do this, select the Move Graphics window, which gives me the grabbing hand, which lets me move things around. But if I hover, when I have this tool selected, if I hover over the axis and then left click and hold, I can then drag and change the axis scaling. So I'm going to drag it out past 10,000. And at some point, you'll see that exponential model. And then I've got to adjust the output axis as well, because we had pressures all the way up to 1,000 millibars. So there's a window that shows more than, we graphed it from 0 to 10,000 for our scatter plot. This has me going out much further than that now. But I've got to adjust the window to be able to see the graph. That's the key. So now you can think about, once I've got the model, what are the kinds of homework questions that you could be asked? And we want to realize that the homework questions that you're asked are questions that you really, when you're working with data, you ought to be asking these types of questions yourself. You're being prompted in a homework to ask the types of questions you ought to ask. So the first important question would be domain and range for this model. Well, this model is based on the Earth's atmosphere, so we need to think about where we as humans would encounter the Earth's atmosphere. So probably for my domain, I would be thinking about, hey, what's the lowest I can go? So the lowest land on Earth is 1,355 feet below sea level over in the Dead Sea in Israel. So that would be negative 1,355 feet. I'm going to write that down. And then what's the highest I should bother using my model? So, most of the Earth's atmosphere, so the Earth's atmosphere is 300 miles thick, but most of it is within 10 miles of the surface of the Earth. So maybe we want to use that 10-mile limit as kind of the end point. Again, domain and range, there isn't always a perfectly correct answer. You just have to come up with something reasonable And most importantly, on homeworks and exams, you need to explain why your selection is reasonable, and your explanation needs to make logical sense to the reader in order to score well. So I'm going to say, hey, we're going to go from negative 1,355 feet all the way up to the 10 miles where the atmosphere is mostly prevalent. And so that's going to be 52,800 feet if we convert miles into feet. So I would say, hey, for my domain, let's go from the negative 1,355 dead sea. And that means my range is going to be driven by what type of output is that giving me. So in my input bar, I can take the name of my model, which is P. The name of my model is P, and then using function notation, I can put my parentheses in. And this is why function notation is so powerful. I can just type the input in, negative 1,355, enter. And so I see that at the dead sea, or negative 1,355 feet below elevation or altitude, I would expect a air pressure of about 1,188.9-ish millibars. And then if we went 10 miles up, that's going to be 52,800 feet, because there are 5,280 feet in a mile. So I plug that number in the input bar into my function, and I can see that I would expect about 5.3 millibars of air pressure. So the moment I do that, I can establish, if I'm working in a homework, I can give a domain and range on this. I can say, hey, I'm going to let my altitudes run from negative 1,355 feet at the Dead Sea up to the 10 mile mark, which is 52,800 feet. The atmosphere, even though we still have some, is so thin after that point it probably doesn't make sense for us to really talk about it. And then that's going to make my pressures run from what's the lowest pressure I have. I can see right here it's about 5.3 millibars, and it's going to run up to about 1,188.9 millibars. So that drives my domain and range. But I've got to be able to justify these numbers. I have to say something reasonable that I would expect a reasonable person to accept as being true. So domain and range. And we could also use our model to make predictions. I could say, hey, at what elevation do I expect, say, air pressure to be 800 millibars? And in a previous assignment, we saw that all we need to do for that is to take, if we're interested in the altitude at 800 millibars, I've got to get rid of the pin tool. There's the select tool. I would just type in y equals 800. And the line y equals 800 is going to intersect with my model. And if I am not doing handwork, then I can just say, under the point menu, I look down and say add an intersection, and then hover over that intersection and click. And then hopefully GeoGebra doesn't crash on me. There it adds in the point A, and the point A says, hey, to get an 800 millibar output, I need to be at an elevation of about 2,606 feet. And I could do other things. I could say, hey, if I climb Mount Rainier, what do I expect the air pressure to be when I'm at the top of Mount Rainier? And Mount Rainier is 14,411 feet. So I could just type in my air pressure model down here in my input bar. I could go pressure as a function of elevation, but the elevation I'm interested in is 14,411 feet, and hit enter. And then the output to that pops up right here. You can see when I hover over it, even it says P. It tells me what C is. C is the pressure model evaluated at the 14,411, and this says, hey, the air pressure I would expect at the top of Mount Rainier is about 245.7 millibars. So once we get the model using Excel, we can answer all of the typical types of homework problems that we could be asked regarding the model. Again, domain and range, it's a matter of trying to come up with something reasonable, and what we really need to understand is on the homework and exam responses in particular, We're looking for a thoughtful response, and the points you earn on those domain and range questions when we're doing modeling should never go from negative infinity to infinity, and it should always be values that you've argued for their reasonableness. If you aren't saying something when it says explain, then you're losing the bulk of the points.